Okay, so excuse me. These are just a few supplemental problems for section 5.5 for pre-algebra, just to kind of give you another avenue to kind of look at some similar examples to what we did in class. First thing I want to talk about, though, is kind of going through the general guidelines for solving an equation or an inequality. For the most part, it's all the same process, except when it comes to multiplying or dividing by a negative. There's more to it than that, but what we see in pre-algebra, that's all we really have to concern ourselves with. So first step on any of these problems is to simplify each side. That might mean there's a distributive property to do. That might mean there are like terms to add together, or a distributive first, then add like terms. Either way, this is the first step for all of these problems in this section. And this is general for everything. We just normally get to skip step one. Step two, move all the variables to one side of the equation or inequality. It doesn't matter which. Generally, people prefer to move them to the left, but it doesn't matter. You can move left or right. Just move them all to one side. Step 3, move all the numbers to the opposite side of the inequality symbol or the equation sign. And then step 4, multiply or divide to solve. And then again, note, if you multiply or divide both sides of an inequality by a negative number, you must flip the inequality symbol. Okay, so let's look at some problems. First, nice straightforward equation here. 3 equals 4 times the quantity x plus 2. So the first thing we address is that there are parentheses on the right-hand side, meaning I'm going to have to distribute the 4 to both sides. So that will give me 3 on the left. 4 times x is 4x. 4 times 2 is 8. And there's our first step. And now we're just back to solving equations like we did into chapter 4 and what we've done for the first part of the chapter. Subtract 8 from both sides. That gets the x term by itself because it's already on its own. Negative 5 equals 4x. Divide by 4. Negative 5 fourths equals x. If you want, you can make this negative 1 and 1/4, but again, for my class, unless it's a story problem, contextual problem, leave it as the improper fraction. I'm okay with that. For number 2, it's an inequality, but it's very similar. A number times parentheses, other side of number. Number times parentheses, number on the opposite side. So first thing we'll do is distribute the 4. That gives us 4b minus 12, because 4 times b is 4b, 4 times negative 3 is negative 12. Less than or equal to 72. Then we've got the b's together on one side, so it means we just need to move the numbers to the opposite side. So add 12 to both sides. 4b is less than or equal to 84. And then now we divide by 4. And since I did not divide both sides by a negative, in fact there are no negatives to be had except for the negative 12, which we canceled out by adding 12, I do not have to flip that inequality symbol. I can just leave it as it is. Okay. Alright, another couple problems. Now you can see they're both very similar in this case. There is some distribution, and this one is just one side, this one is two sides that have distribution, so we'll come back to 4. But the first thing we're going to have to do is look to simplify each side. 12m and 12 are not like terms, so I can't combine them. And I've got 6 times the quantity, which means I have to distribute. So I'll just bring the left-hand side down. 6 times 3m, 6 times 3, that gives me 18m plus 18. And now I'm at a point where I have to make a decision. I've got variables on both sides of the equation. There's no wrong choice here. I have to move them to one side. But what I've noticed a lot of people over the years prefer to do is to keep the variables positive if at all possible. So there are more m's on the right than there are on the left. So I can subtract 12m from both sides, canceling these m's off and giving me a positive 6m over here. So that's what I'm going to choose to do. That cancels off. 18m minus 12m is 6m plus 18. Now I just got to move the 18 to the opposite side while I'm adding 18. So to undo an addition of 18, subtract 18. That gives me negative 6 equals 6m. And now divide both sides by 6. Negative 1 is equal to m. Or if you don't prefer to have the variable on the right, you just reorder it. M equals negative 1. Again, I'm okay with either. Just be aware that on the semester exam or any multiple choice test you ever take, it'll be variable on the left, number on the right. Now for number 4, it's really just like number 3. The only difference is you're going to distribute on both sides first and then have the same issue of variables on both sides, numbers on both sides, and where do you go with it. So distribute the 5 to both terms on the left. That gives you 5n, and then 5 minus 3 is negative 15. Distribute the 3 to both sides. 3 times n is 3n. 3 times 7 is 21. Now, in this case, again, people tend to move them to the same side that keep the variables positive. In this case, just subtracting a 3n will do that for us. Cancels them off from the right. 5n minus 3n is 2n. Then I have 2n minus 15 equals 21. So now I can move the 15 over to this side to get the n's by themselves. So add 15. 2n is 36. Divide by 2. N is 18. Next example goes back to more complex inequalities. So we have negative 2 times the quantity k plus 1 is greater than negative 16 plus 5k. Now in this case, we are going to be stuck with kind of a weird situation of either having negative variables or moving them to positive variables, but then having to flip the symbol at the end because the way we're going to have it written is going to look awkward. Either way, we start off both sides the same as every other problem. Make sure there's nothing that can be simplified on each side. Well, I can on this side distribute the negative 2. On the right-hand side, they're not like terms. I'm just going to leave them alone. So negative 2 times k is negative 2k. Negative 2 times 1 is negative 2. That's greater than negative 16 plus 5k. And now this is that awkward decision. Do I add 2k to both sides, making it positive 7k on the right? Or do I subtract 5k, moving them to the left, which is how people feel more comfortable, but then giving me a negative k? I'm going to do it both ways just to show you get the same answer, but it's a decision you're going to have to make. So first, I'll subtract the 5k and move them to the left so that we kind of keep comfortable with how people tend to like the variables. So negative 2k minus 5k is negative 7k minus 2, which is greater than negative 16. Now to get rid of that negative 2, add 2. That gives me negative 7k is greater than negative 14, because a negative 16 into 2 is negative 14. And now I'm going to divide both sides by a negative, which means this has to become flipped and be k is less than 2. There's our solution. Now, if at this point here I had decided to leave it as negative 2k minus 2 is greater than negative 16 plus 5k, but move the k's to the right because I want to keep k's positive, I'm going to get the same answer. It's going to look differently though how I get there. So I add 2k to both sides. This becomes negative 2 is greater than negative 16 plus 7k. Now I will add 16 to both sides. Negative 2 plus 16 is 14, which is greater than 7k. And then divide by 7. Now I didn't divide by a negative, so I don't have to flip the symbol. But 14 divided by 7 is 2. And that becomes k on the right, because that cancels off. Now notice, I've got both answers up here, and this problem we'll get to in a second. I've got k is less than 2 here. This one is 2 is greater than k. These are both the same statement. They mean both the exact same thing, but they're written backwards. Generally, this is the preferred method. Anytime against standardized test, ACT, our semester exam, you're always going to see variable, symbol, number. If you have number, symbol, variable, it could still mean the same thing, which it does. The open end goes to the 2, the smaller end goes to the k. Open into the 2, smaller into the k. It's just that it's not preferred to have it written that way. So when you get done, you can swap the k and the 2 and then flip the sign back and make sure the smaller part's with the variable this time. They're both the same thing. And if I go to graph this one, because the homework a lot of times does say to graph inequalities, 2 is my number that I'm looking at. Number to the right of it is 3, number to the left of it is 1. Since it's just less than, I do not want to include it, so open circle. And then I want to go to numbers that are less than 2, because I'm saying k is the smaller one of 2. Well, what's smaller than 2? 1 is, so my arrow goes towards 1. Now for the next problem, just for the ease of things, I'm going to just move the variables to the left automatically, deal with the negative, and just solve. I'm not going to do both directions. Other than that, it's really the exact same problem as the last one. Left side is simplified as far as it can go. It's 2p plus 5. They're not like terms. And then I'll distribute the 3 to both to the right side. So it'll be 3 times p, 3 times negative 6. So 2p plus 5 is greater than or equal to 3p minus 18. Now I'm going to subtract 3p because of the fact that I want to cancel off the 3p and move them to the left. And a positive 2p, because again there's an understood plus sign in front of there, and a negative 3p gives me negative 1p, plus 5, which is greater than or equal to negative 18. Now I'll subtract 5 from both sides to get the p term by itself. That gives me negative 1p is greater than or equal to negative 23. And now I can divide both sides by negative 1. But I divided both sides by a negative, so I have to flip that inequality symbol, and this becomes p is less than or equal to positive 23. If I go to solve that then, what I end up getting is a number line. 23 is the center, 24 is the number to the right, 22 is the number to the left. Since it's less than or equal to, I want to include 23, so it's a solid dot, and less than means left of 23, because 22 is less than 23. The next couple questions are weird cases of things that can occur with equations. They don't happen very often, but when they do happen, you have to be aware of what happened, because this sometimes works out and you'll do a problem and you think you did everything right and it doesn't solve, or it has infinite solutions. Or more importantly, do something wrong and you think it does solve and it doesn't. So this problem is just simply distribute to both sides, add like terms, all that good stuff. But in the end, we're going to get a little weird twist to it. So distribute the negative 2 first and left. Negative 2 times 3r is negative 6r. Negative 2 times 4 is negative 8. Combine like terms here on the right. Negative 5r and negative 1r. They're both negative because it's negative 5r and then it's minus 1r. That's negative 6r minus 8. Now what ends up happening is I decide to add 6r. It doesn't matter which one I decide to move, but I'm going to have to move one of them. And I get this little weird thing to happen where both r's cancel off. And I get a true statement then. Negative 8 equals negative 8. If that occurs, if every variable drops off, what that means is I actually have infinite solutions I can choose. Any number I want to choose at all for r in this equation would work. So for instance, if I wanted to say, okay, let r equal 0, I'm doing it as a check. Be negative 2 times 3 times 0 plus 4 equals negative 5 times 0 minus 8 minus 1 times 0. Well, 3 times 0 is 0. 0 plus 4 is 4. So I get negative 2 times 4, which is negative 8. Negative 5 times 0 and negative 1 times 0, those are just 0. They cancel off, and I get negative 8 again. So both sides checked out when r was 0. However, if I pick any other number, like let's say 1, pick something nice and easy to work with, I'll let r equal 1. It would be negative 2 times 3 times 1 plus 4 equals negative 5 times 1 minus 8 minus 1. So I just replaced all the r's with 1's now. 3 times 1 is 3. 3 plus 4 is 7. So I have negative 2 times 7, which is negative 14 on the left-hand side. On the right-hand side, I have negative 5 minus 8 minus 1. When I do all the 1 multiplications, that's also negative 14. That also checks out. So for this problem, both 1 and 0 worked. And that's because when the variables drop off, and this is true, it means any number works. So your solution, you could say all real numbers, all solutions, infinite solutions, whatever you want to use, I'm okay with it. Most of the time we just say all real numbers. That means any number I want to choose will work. Now, on number 8 then, this one here, this is actually kind of the backwards form of that. I'm going to solve. Okay, on the right-hand side, I'm going to have to distribute the 4. Okay. I get 14 plus 8w equals 32 plus 8w. I subtract 8w from both sides. That cancels off. And then I get 14 equals 32, which is not true. What that means is no matter what I do in this problem, there is no number for W that will make these guys true. No way I can plug anything that'll work because they'll always inherently be false. So that means there's no solution. I can't spell all of a sudden. No solution. Sometimes they call it null set. Null just means no. Or something like a 0 with a line through it. Any of these work. So for me, personally, I prefer no solution.